Question of the week from the Naked Scientists.
Hello, and welcome to Question of the Week. I'm Liam Messon, and this week we were sent a rather magnetising question by Tim Harvey.
If you start with a magnet with a north and south pole and break it into half, you get two separate magnets, each with their own north and south poles. So how does it know it's been broken? What causes the change? And where does it get the energy to do this?
So why is it when we break a magnet in half we get two new magnets? Why don't we just get separate north and south poles formed? Luckily there was a second Tim Boyd, a Cambridge undergraduate, on hand to set me straight on this polarising issue.
Thinking of magnets as having a north and south pole is slightly misleading. They have a thing known as a dipole. This means that they have one pole with a north and south end. But it is a little more complicated than that. What we think of as a magnet, a bar magnet, is made from lots of little magnets all pointing the same way as each other. These little magnets are called domains, and each has its own dipole, so a north and south end. Therefore the strength of the magnet is the total of all these little magnets. However, if all the little magnets pointed in random directions, then the total would be zero. There would be no magnetisation. Before, you may have been told to be careful not to drop magnets. This is because if we shake around all the little magnets, they will no longer point in the same direction, and so the magnet will no longer be magnetised.
Noted. Don't drop magnets. But wait a minute, how do we get our little magnets all lined up beforehand?
We do this by putting the magnet near a really strong magnet, which then pulls all the little magnets to point in the same direction. If the really strong magnet is then taken away, there is nothing to pull the little magnets away from pointing in this direction, so they stay happily pointing in the same direction, and we have magnetisation.
To make a magnet, we need a magnet. Luckily, there are both naturally occurring magnets and electromagnets for this task. However we make them, we always get the situation of loads of little magnets all pointing in the same direction. So what happens when we break a magnet in half?
You split it into two magnets made of lots of little magnets, all pointing in the same way. So if the right-hand end of the original was north and the left-hand south, then the right-hand end of the two new magnets would be north and the left-hand end south. The direction of the dipole hasn't changed. The north end and the south end are still in the same place. The strength of these new magnets is half that of the original, as it is made from half of the little magnets. The magnet doesn't need to know it has been broken or change its magnetic structure. It already has the new poles.
It turns out that it's magnets all the way down. Thank you, Tim Boyd, for answering our question, and thank you, Tim Harvey, for asking it. And for next week, Mitchell wants the answer to this burning question.
This has always baffled me. Why doesn't water burn? It is made of two of the three things that you need to make a fire, fuel in the form of hydrogen and oxygen, and yet it doesn't burn. My mum says that it's because it is wet, yet oil, petrol and many other wet liquids burn. Why do these liquids burn?
If you know the answer or have a question of your own, tweet us at The Naked Scientists, send us an email on chris@thenakedscientist.com or post in our forum on thenakedscientist.com. That was Question of the Week from The Naked Scientists. Thanks for listening and bye for now.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.